All right, we're going to go over how to name binary type 1 compounds. And so binary means it contains only 2 elements. And type 1 compounds are formed with a metal that always forms the same charge. Right, so the first metal always forms the same charge. And so, if we remember, the metals in group 1A always form a +1 charge, 2A a +2. Then we have aluminum that always forms a +3, zinc a +2, cadmium a +2, and silver a +1. So if we're looking at a binary compound and a metal from this group, group 1A, group 2A, where one of these 4 elements is the metal, then that's a binary type 1 compound. And so let's look at an example of a binary type 1 compound. So say we have a Na and a Cl, right? So sodium is here in group 1A of our periodic table, so it's always going to form a +1 charge. So the metal is connected to a non-metal. Chlorine is over here. It's one of the halogens. So this would qualify as a binary type 1 compound because the metal always has a +1 charge. So when we're trying to name these, we're going to look at what this first element is and determine if it's a metal or a non-metal. If it's a metal, it can be type 1, such as this, where the metal always forms the same charge, or we can have a type 2, where the metal is one of these metals in here that forms a variable charge. So in this case, the binary type 1 compound fits because we have a metal that always forms a +1 charge. So in the naming, the metal gets to keep its name, so this would be sodium. And then the nonmetal, which is chlorine in this case, changes the ending of its name to chloride. So chlorine becomes chloride, and this becomes sodium chloride. So that's how we would go about doing this. So there's 2 directions you can go, where you have the formula and you have to come up with a name, or else you can start with a name and have to come up with a formula. So if we had this name, potassium bromide, right, then we would have to find these elements in the periodic table. So we would come over here and find K stands for potassium, and is a type 1 compound, right, or a group 1A compound, so it's a metal that always forms the same charge. So then we would write the symbol for that metal, potassium, and then the bromide, the IDE ending tells us we have an ion made out of bromine, and so then we drop the IDE and realize that it's actually bromine, so we'd have KBr as potassium bromide. So that's kind of the way we'd go about naming these. There's the 2 directions you can go. Right, and so the other thing to realize here is that the charge has to be balanced. So sodium has a +1 charge, chlorine is from the group that has a -1 charge, so those go together 1 to 1. Potassium is in the group that has a +1 charge. It's connected to a bromine, which has a -1 charge. So that isn't always the case that the metal and the non-metal go together in a 1-to-1 ratio. So if we take a compound like sodium oxide, right, this we see there our metal is sodium, so this is a type 1 because sodium is here in group 1. But the type of cation that sodium forms has a +1 charge. And oxygen is here in group 6A, so it forms a -2 charge. So oxygen has a -2 charge. So those cannot go together 1 to 1, or you wouldn't have a neutral compound, you would have a -1 charge. And so what you can kind of do is do this thing where we say, well, we need 1 of these and 2 of these, this little cross multiplying trick, and then you can see they go together as Na2. Oh, and that would be sodium oxide. The other way to kind of do this is like a little accounting kind of way of doing it, right? So this has a -2 charge, this has a +1 charge. So if we have two of these, we have a +2 charge. If we have one of these, we have a -2, and if we add those together, it's 0. So the sum of the positive charges has to equal the sum of the negative charges. So whichever way you find easier, you'll have to be able to figure out how many of one go with how many of another based on the charge they have and where they are in the periodic table. So say we see something like CDS and we want to name that. The first thing we're going to do is determine if the first element is a metal or a non-metal. And in this case, cadmium is one of the transition metals. It's here in the middle part, right? And it's always forms a +2 charge, so this is a type 1 binary compound. So cadmium just keeps his name. And the sulfur, if we find our S, he's over here with a -2. The sulfur changes its ending and becomes sulfide. So then we have cadmium sulfide. And we could try a couple more if we want. We could take, let's say we take and go the opposite direction where we have a name, calcium, and what ending we want to put on that? Iodide. All right, so if we have calcium iodide, this tells us we're dealing with calcium. Calcium is here in a group 2A, so it always forms a +2 charge. So we have calcium with a 2+ charge. Iodide, the ID ending, we drop that and put back the INE ending. Iodine is one of our halogens here in group 7A, so it forms a -1 charge, right? And so what we can do again is the cross multiplying. We have 2 here, we can transfer the 2 over here, we have a 1 here. We can transfer the 1, so we need 1 calcium and 2 iodine, right? And so we have a +2 charge here, and we have 2 -1 charges. So we have a -2 charge and a +2 charge. So overall, we have a 0 charge. So this would be the correct ratio for calcium and iodine. I'd say we look at something like Mg3N2. So if we're trying to determine how to name this, we look at the first element and determine if it's a metal or non-metal. In this case, we find magnesium on our periodic table up here. It's a metal. It's a metal that always forms the same charge, so it's a type 1 compound. So magnesium keeps his name. And nitrogen changes its ending to IDE. So we have magnesium nitride. Right? And that's how we name type 1 binary compounds.